Let's explore the tokenomics of the Posemesh, the DePIN for AI perception. The Posemesh is a decentralized machine perception network, making it possible for multiple devices, robots, and AI to collaboratively understand their physical environment. This is necessary for things like robots, navigation, self-driving, shared augmented reality, and smart cities. We believe this protocol will ultimately replace the GPS and centralized positioning services with a technically superior and morally superior alternative: civilization-scale infrastructure funded, owned, and operated by the people themselves, earning rewards for pooling their resources to create the foundations for the future of AI, robotics, and smart cities. Although decentralized physical infrastructure networks, like the Posemesh, can be deployed on vast, even global substrates, they always have a knowable, finite supply of resources. When dealing with the exchange and trade of finite resources, it is important to have the resource's value be represented by something that has a finite supply of its own. That's why the Posemesh needs a cryptographically secured and finite token. As a decentralized machine perception network, the limited resources of the AUKI Posemesh are things like bandwidth, storage capacity, compute power, and battery. Users of the Posemesh are either trying to learn more about the world through other people's sensors, or to save valuable resources like time, storage, compute, and battery by asking for help on the network. As with any finite resource, the demand for the resource will impact its market price. The more participants vie for the limited resource pool, the more expensive each unit resource becomes. One of the many challenges with decentralized physical infrastructure networks that have a native token is how to maintain stable provisioning, making sure there's enough service providers, and attractive pricing, making sure that the prices don't fluctuate to the point of the service becoming practically unusable. If the rewards for participating are paid out in the native token, providers may find that their work is not sufficiently compensated when the token price is low. This will of course lead to them leaving the service, reducing the provisioning of the network. But the same is also true on the demand side. If the services are paid for with a native token, with prices denominated in the token, the cost of the service becomes unpredictable, and the service becomes unreliable and unattractive to builders. The AUKI Posemesh uses an innovative burn credit mint economy that allows for the scarce resources of service and data to be exchanged at a predictable price unaffected by token price fluctuations, while still offering attractive rewards to the service providers. A common complication for DePIN projects is the cold start problem. There will be no demand for the service before it is reliably provided, but the network cannot sustainably afford to pay for over-provisioning. Simply put, no one wishes to supply service before there is demand, and there can be no demand before there is supply. To allow for early provisioning, the network must disproportionately reward its early supply-side participants. It may even be necessary to incentivize early demand-side participants to use the network instead of its competing alternatives. Since no network can sustainably reward both supply and demand, network effects become crucial. Network effects refer to the phenomenon where the value of the service increases as more people engage with it, leading in turn to increased supply of service and greater value for all participants. The AUKI Posemesh protocol requires participants to stake a reputation in the native AUKI token. This reputation is token denominated, meaning it is cheaper to participate when the token price is low. Rational DePIN operators that believe that there is future demand for the service will choose to participate early so as to reduce the cost of joining the network when the rewards become compelling. The AUKI Posemesh rewards themselves are also token denominated, meaning rewards increase when the service and participation is in higher demand. Rational DePIN operators may choose to hold their token earnings so that they can continue to earn rewards when demand is higher, or sell their tokens at a higher price to allow new participants to stake into the network instead. By allowing the service price to be dollar denominated while making protocol participation and rewards token denominated, the Posemesh economy addresses the common challenges faced by other DePIN projects. It's a design tailor-made to allow for the bootstrapping of civilization-scale infrastructure owned and operated by the people. In the AUKI Posemesh economy, supply-side providers or operators make some of their resources available to the network in exchange for participation rewards and performance rewards. The network can in turn use these resources to provide a service to the demand-side participants, the developers building on the platform. For the developer to be able to purchase services from the Posemesh, they must first send an appropriate dollar-denominated amount of AUKI tokens to a burn contract. In exchange, the developer will be granted a credit balance with the Posemesh, representing a claim on pre-purchase services. These credits are non-transferable and can be consumed by the developer's robots, AIs, and applications over time. Each burn results in an immediate deflationary mint that goes into a reward pool. As developers spend their credits on services, the reward pools issue tokens to the operators who provided their resources. The more credits are spent by the developer on a particular type of service, the more rewards will be earned by the participants supplying the data and resources. The rewards are paid out in the AUKI token from the reward pool, which was previously replenished by the deflationary mint at the time of the burn. So to summarize, the burn cost of creating credits is dollar denominated. You burn a fixed amount of dollars for a fixed amount of credits. The price of the service itself is credit denominated, meaning you pay a fixed amount of credits for a fixed amount of service. The rewards for providing the service are token denominated, proportional to the amount of tokens that were burned to create the credits consumed. Let's dive into the deflationary mint. Whenever consumers burn AUKI tokens, the protocol creates a smaller deflationary amount of new tokens and places them in a reward pool. The deflation rate starts at 50%, meaning that for every 2 tokens burned, only 1 new token is minted. Over time, the deflation rate is adjusted asymptotically towards 0 as the total supply of tokens approaches 50% of the initial mint at network launch. What this means is that the Posemesh starts with an initial supply of 10 billion tokens, but will eventually reach an equilibrium of only 5 billion tokens. This deflation mechanic creates extra incentive for early adopters to hold their tokens for a longer period, as deflation rates are the highest when the protocol is gaining its initial traction. To ensure its ability to continuously invest in protocol improvements and necessary provisioning, the protocol may impose a small tax on each mint. Building a decentralized network takes time and happens in steps. You need to manage the token economy and the Posemesh network until such a time that the network is sufficiently decentralized that it can sustain itself independently. To this end, the network needs to establish a treasury and a foundation to manage that treasury. In the beginning, this is done by AUKI Labs, the original creators of the protocol. But as more organizations start contributing to the Posemesh, its governance will become increasingly decentralized over time. The Foundation's mandate is to establish a universal spatial computing protocol and a decentralized machine perception network for the next 100 billion people, devices, and AI on Earth and beyond. Their job is to create the token economy and its policies and oversee the gradual open sourcing of the protocol so that it can thrive. To ensure that the Foundation acts in the best interests of the network, they are granted a substantial portion of the initial supply as a treasury that it uses to accelerate network growth on both the demand and supply side. By giving the Foundation a treasury, the network creates an incentive for the Foundation to act to increase the demand for the service and the token, because the more desirable the service and its token becomes, the greater the market value of the treasury becomes. The Treasury is vested over a 6-year period, making sure that the foundation has a long-term perspective on protocol growth. In the service of their mandate, the foundation will issue grants to application developers to increase demand generation and provide participation rewards to service providers for healthy over-provisioning in regions of interest to the network. As mentioned earlier, the Treasury can be gradually replenished over time through a small tax on the deflationary mints, but they cannot mint new tokens out of thin air. New tokens are only created when people use the service, and it is never inflationary. So what does all of this mean from a game theory point of view? How will the different actors and stakeholders behave to maximize their self-interest, and how does that impact the protocol and your participation? When the token price is low, developers end up burning greater amount of tokens because the cost is dollar denominated. This accelerates the deflation of the total supply when prices are low. When the token prices are high, consumers burn fewer tokens for the same amount of credits, meaning fewer but more valuable tokens are paid out to the providers. If price stability is a priority for the consumer, the rational service consumer will burn their tokens immediately after purchase, because as long as there's no lag between the purchase and the burn, the service consumer has complete overview of the cost of interacting with the Posemesh. This incentive to burn further accelerates the deflation. Since reputations are token denominated and locked for the duration of the smart contract between the participant and the Posemesh, operators are implicitly making a prediction that demand for the Posemesh will be stable or increase over the contract period, or that the rewards during the contract period will exceed the potential loss in value of the stake. When the token price increases, so does the value of the existing rewards pool, but the upfront cost of joining the Posemesh and staking a reputation would then also be greater. This creates an emergent prediction market where rational operators will buy tokens when the price is low to make sure that they can afford to act as operators when the rewards are high. If the rational operator believes there is insufficient demand for the service or that the demand will go down, they will choose to not stake their tokens or even put them back into circulating supply. If the operators start selling their tokens, that pushes down the price of the token, which triggers a new epoch of increased deflation, bringing the token price back up. This mechanism prevents death spirals from happening as long as there is actual demand for the service. This way, operators collectively and implicitly balance the provisioning of the Posemesh service without a central authority. If there are too many operators compared to demand, rewards will be too low to incentivize further provisioning. The DePIN network can balance itself thanks to this innovative burn credit mint mechanism invented by AUKI Labs and increasingly copied by other DePIN projects. If you enjoyed this video, you should read the Posemesh white paper. You may also enjoy this explainer video about why the Posemesh is so important, or this keynote presentation about why DePINs like the Posemesh are about to fundamentally rewire civilization. The AUKI token is launching soon, so make sure to follow us to keep up to date with the latest. See ya.